Hope you guys are doing well. This is Akash Chauhan again. And in our previous lecture, we have covered the header files and the namespaces with the appropriate examples. In today's lecture, we will focus on the data types, and we have different data types in C++. We will talk about each one of them. So without any further ado, let's discuss about the data types in C++. Okay. So before moving ahead, let me write a small definition of data types. Okay. So it will be super easy for you to understand what the data types are in C++. So let's say we have some kind of a data here. Okay. This is data and this is memory. Okay, we using the CPU and MMU, memory management unit. We access the data. Okay, store the data in memory. We read the CPU reads the data from the memory and get back to the user. Let's say user is here. Okay, user enters some data or receive. Let's enter some data over here. So CPU is somehow handling with working with the memory part, and the user would be working with the CPU and the memory management unit. But if you are able to see that the user is not directly connected with the memory here, right? So what would be the use of this data type then? Okay, let me write a small definition. It is saying different types of data are stored in memory. So different types of data are stored in the memory. That is why we are saying data types in C++. It means there are different types of data will be stored in the memory, and C++ compiler would be identifying the different kinds of data stored in the memory to interpret what the programmer has written. Okay, so suppose we have heard about the integer, float, all such kind of data types we have heard, right? So the compiler is saying that I understand something by saying integer, I understand different by saying if I say it is a float. So at memory, at somewhere in the memory, the meaning of this would also be different. If I'm saying at the user point of view, I'm saying it's integer, it's a float, then definitely at the memory point of view, also these things would take different sizes at the memory side as well. So it is saying that we are going to discuss about the different types of data stored in the memory. So this is about the data types in C++. We have three major data types in C++. Let's say the first one is, instead of doing so, let me draw a picture. So this is data type. The first one is primary data type. Second is derived, and third one is user defined data types. Okay, so we will discuss about all three data types in detail, but at this point of time you must aware that we have categorized whatever the data we are going to store in memory using C++ will only be stored in these three types only. Okay, so let's say we have created a data in G++ compiler. Okay, then somehow it will be stored any of these three portions, any of these three types of data. Okay, we cannot define anything in our program that will not map to these types of data types. They somehow fall into at least one of the categories. or let's say at most of the one category, because if we are saying it's an integer, it will fall into this category only, primary data type, not the derived, not the user defined, because we will discuss about these things in the later uh, notes. But so far you must understand that we have different types of data that we have to store in the memory. So we have defined some kind of data types. Predefined data types are actually what to say, decided by the compiler itself. So primary data types are the inbuilt data type. Derived data type means you have done some small modification with the primary data types. Okay, that is why we say these are derived data types. User defined, it means user can define their own data types. We will discuss about this type. This is very interesting. Okay, so this is the overview of data types. So let me give you a little groundwork before moving ahead. The groundwork would be, let's say we have this example, uh, int a equal to 10. Okay, so instead of directly assigning the value, let's say it's an integer a and we are assigning 10 in the second. So what is happening? We are saying we have chosen integer data type and a is the name of the variable and this is the value. Okay, so this part of the program, when we don't assign the value, this is called the definition or the declaration of a variable. When we assign a value means we are assigning a memory. We will see why I'm saying when we assign a value, it means we are providing some kind of a memory, either a stack or heap. We will talk about that. But when we are going to assign a memory to the variable, okay, it means if there is a memory, the value can be stored in the memory. So that's why we are saying if we have assigned a value, it means we have defined definition of a variable. So let's see the motivation behind that. So let's say this is the heap. Okay. So as we know, integer is a 4 bytes data type, and the memory location of this point at this point is 1, 0, 3, 4, 5, 6, 7. Okay. Uh, and this is, we know that this is the integer data type, that's why it will take 4 bytes. If it's a 4 byte, then we will add up the 4 byte here and it will become 1, 0, 2, 3, 4, 5, 7, 1. Okay, this memory address. So it will store integer value. So the integer value, it means we are saying, let's say we have assigned the data either on heap or stack. If it's a local variable, we will assign it a stack. If it's a global variable or we have chosen a dynamic memory, then we will be assigning the memory at the heap only. Okay. So let's say this is either the heap or the stack. Okay. So here in these 4 bytes, okay, a different type of blocks and chunks would be there. So in these 4 bytes, the integer value will be stored. So as I said, it is a 4 byte. It means this memory holds a value, and value is 10. It means the binary of 10 will be stored here. Okay, it is the actual data. Okay, this is the starting point of your memory. This is the size of your memory. This is the end point of your memory. So end point is nothing but, if you look at it, end point is nothing but the start plus the size of your data. You can calculate the endpoint by yourself. Okay, so why it is important? So this is also very important, that what was the motive behind the creation of the data types. Why the inventors of this compiler, they have created different data types like integer, floats, character. What was the main motive? There would be some kind of need. That's why they have invented all these data types, these primary data types. I'm talking about the primary data types at this point of time. Okay. So the motive behind all those things would be, let me discuss this. Let's say your CPU memory reader is here. Okay. CPU memory reader is here at this address, at this point of time is somewhere here. Okay. And if this CPU doesn't have the information that this is the integer, then how many bytes from this address to where it will stop to read? Okay, let's say there is a default block size, let's say 2 bytes. If CPU doesn't have, it will only read 2 bytes. So it will read only this type of data. If we don't assign the data is integer type, it will only read this data. And how about this data? So it means if there is a CPU memory reader, it should have the information that you are going to read the integer. So always read the bytes in the multiplication of the 4. It means always read, let's say you are going to read 2 blocks, 3 blocks, it means you must read 12 bytes from the starting address. Otherwise, the data may be incomplete. So in that case, we must pay attention that the data may be incomplete. Okay, if it is reading the memory in the multiplication of 4, it means because it is the CPU knows that the here the bytes are 4 bytes are stored as it is an integer, then I need to read 4 bytes multiplication memory. It should multiply by the 4. Okay, if I'm going to read 4 blocks, it means I can read 16 bytes, but I should not read less than 4 bytes because it's an integer. So, and let's say this is, there will be a data loss, right? Here, if we don't read this and we will go by the default size of the block, it will not read the actual data. Okay, so what is what if we have assigned all the data types, let's say character, float, int, long, we have assigned the default block size. It would be great, right? Let's say 2 bytes for all data types. Then this problem wouldn't arise. It will always read 2 bytes from the starting location. It will read the data. But if you look at it very carefully, then you would understand the need of designing all these data types will be disappear. Okay, the need of designing all these different types of data will disappear. Why? Because we are saying that if there is a character, it means it will only fall to 55 value. It means you don't need to assign 4 bytes to that. 1 byte would be enough. We will learn more about this in the next lecture, but you must understand that the character is 1 byte long. It means we have 8 bytes, 8 bits here, 7. Let me, okay. So you must understand it is saying that character only require 8 bits. So you don't need to spend 4 bytes to store the character. Okay, it means we have characterized the data in different formats because we want to save the memory. So by doing so, by designing our data types, we have saved a lot of memory. A lot of memory. So that would be the main motivation behind your designing your different data types in C++. This is the main motive. Okay, if there is no memory optimization, then there is no point of using different data types. We should have used the default block size for each and every data types. Then the need of those data types would disappear. Okay, the need of those data types were there because there was a motive to save the memory, to enhance the CPU reading and writing capabilities, the timings, and reading and writing optimization must have been there. So all these needs were there. That's why the different data types were invented or created by the compiler or the C++ designer. Okay, so this is about the basic detail about the data types. Let me draw a diagram to show you that what kind of different data types we have for in C++. So let me draw a diagram and let me get back to you after drawing the diagram. So guys, I have created a data flow, or maybe you can say this is the diagram of different data types of in C++. So the first category is the primary data type, the user-defined data type, and the third is the derived one. So primary data types, let me write a small definition on each type of data types. Then we can discuss about the various data type inside these data types, the sub data type of the data types we are going to discuss. Okay, so let me write a definition uh, for each and every data type. So guys, I have written the definition of each and every data types. So primary is the inbuilt data type. It means these kind of data types are defined by the compiler or uh, uh, compiler because C++ has some standard. Okay, that a compiler should perform these kind of operations. Okay, these should be the built data type, inbuilt data type should be there in the compiler. So C++ enforce the compiler to have these inbuilt data types. So inbuilt data types, you are not supposed to modify them. You can only use them as suggested by the compiler. Okay, use them only. User defined is something that like the class, the structure, union, type of enum. We will discuss about them, but it is saying that user can define the types according to their needs. They can vary the size, they can define as many as variable they want to. So that's why it is saying that they can be user defined data types can be modified by the user itself, but in the primary data type they cannot modify. The derived data type, the array, function, and pointer, if you pay little attention, we will discuss about them in the next lecture, maybe in today's lecture. Let's see if time permits, then I'll cover the data types in detail in today's lecture, but I don't think so. So the derived data types actually made out of this primary data type with little twist. Let's say we talk about the array with little twist. It means array, we have integer array. Let's say this is the array, but if you pay little, what type of integer the array is? The integer. This is a primary data type, right? So it is made out of the primary data type, but with little twist. It is saying it is a collection of integer data, right? So these are the basic definition of all these data types. So in today's lecture, we will focus on these primary data types. Let me choose. We will focus on these primary data types today. Okay, we will see what are the different size in the compiler for all these primary inbuilt data types. As I said, these are the inbuilt data type. It means the compiler must have the understanding of all these data type already. It means the compiler would let us know what are the size of these data types, as these are the inbuilt data type with the compiler. Okay, So to do so, let me write something very important before even knowing the size of data types. So let me write a definition. So guys, the size of data types in C++ will always be dependent on two things: the machine, and the second one is your compiler configurations. So the data size will always be the data type. The data size is dependent on the machine plus the compiler configurations, right? So first we need to understand that we have 64 or 32-bit system, the machine. The compiler, let's say we are using which version we are using. Okay, with each version we may have different configuration for the data types. Okay, so there is no point of discussing this thing as a theoretical aspect. I think it would be better if we can know the size of each and every data types we have discussed over here. The void, the first one is void, is the valueless. We will discuss what is the meaning of this void. We use this in function a lot. We have the second one is the boolean. With 0 or 1 character is 0. It's the digits we are going to use for the character. It is integer. Long integer is for the very large integer. Float is including the floating point dot. Double is the very large floating point number. Void character is a different scenario where character has only 1 byte, but the white character has generally, uh, in my compiler, I think it is 4 bytes, but it depends on the compiler to compiler. It may be 2 or 4 bytes. In my case, it is, I think, 4 bytes. Okay, we will see it's a white character. It means the characters you are not going able to install store in the 1 byte, then you can use a white character. Okay, so these are the primary data types as we have discussed here. So let me write a program. Okay, in that program we use this function size of, let's say, and we simply pass data type here. So it would be like this: cout. Uh, let's say we want to know the size of integer. Then we write size of. There is no space. You must understand. No space. Size of, simply type int and line. Okay, and this will print you. The print output of this program would be int, and there is a space, the colon, and the 4 bytes. Probably this is not there because it is understood. Okay, so what I'll do, let me write a program, okay, for each and every data types. Like I have passed an integer over here, then I can pass float and double character, wide character. So let me write a program and we will run it in the Linux, and we will see the different data types according to the system I have, according to the G++ compiler. Here in this case we have G++ compiler, right? So according to the version, we will check the version as well. We will check the system configuration as well, and according to that, according to those configuration, the data type size will differ. Okay, at my system it is different. Probably at your system it will be different. I'm using 64-bit machine, but let's check. Okay, so let me open. Let me pause here and let me open my Ubuntu, and let me write a program over there. Okay, let me get back to you. So guys, this is the program I have written. So this is, I am using this sign. The size of this function is defined in the IO stream itself. So we don't need to what to say, include any other header file. And I'm simply have simply passed the character, short, integer. We have not passed the void, which is void has no memory. Okay, it will assign the memory once you define a value. Okay, so when you we will discuss about the void, but we have not included void here. The long integer we are using, float we are using, double we are going to use. So if I run this program, it will show you the different data type sizes the compiler has. But before doing so, let's check the configuration of the compiler and the system we have. So to do so, let me open the terminal. Okay. So to know the configuration of the system, I think the command is g++ version. So it is saying the G++ compiler is installed over Ubuntu 9.3. This is the configuration of Ubuntu. It is not showing me the detail of the Windows. It is saying, giving me the detail of the Ubuntu. So this is the version I'm going to use. If I want to know the compiler, I think the command is, okay, let me try. Yes, so it is saying that I'm using 64-bit Linux GNU machine. Okay, so now we have two details which are very important. Let me write. As I told you that this is about the configuration, system configuration. So as I said, I have the machine of 64-bit. Okay, 64 bits, and we have the compiler. G++ compiler, it is on Ubuntu 9.3.0. Okay, these are the details. We have this. This is the target. If you can, I can copy it. Let me copy it. So my compiler is actually working on this. So let me copy it here. So this is about the G++ compiler is working on 64-bit Linux GNU. These are the details. These are the configuration file. If you can remember this part, that these are the configuration 64-bit Linux Ubuntu. So the data type size is dependent on the present configuration. If we are using 32-bit and maybe using Kali Linux or something else and using Ubuntu here, like over here, so it may give you the different configuration and the size of the data type would be different. So what I'll do, let me run this program I have written. My program is over here. So let me run this program. I'll go again to the compiler, the terminal. So G++, data type, my program name is data type size in C++ CPP. I will create a executable file or .out file. Okay, to run this and so these are the different sizes. Let me copy the data from here and let's discuss it over the okay. Okay, this is so these are the detail. If you can pay focus on that, it is saying that the character is 1 byte long. Okay, short is 2 bytes. So all these data is in byte format. Okay, these are the default. That's why it is not mentioned. Integer is 4 byte. Long is we can store the larger size of integer into long int. Float is 4. Double is the larger size of float. We can store it in the 8 bytes. Wide character is 4 byte. We will discuss each of these. We have 1, 2, 3, 4, 5, 6, and 7, and the 8th one is the void one. We will discuss about these things, why the size is 1 byte and what is the meaning of assigning a 1 byte to the character. Okay, how many values character can store, what are the different possibilities. We will cover all these things in the next lecture. Okay, so guys, till the next lecture, let's wait and I will cover all these topics. So thank you guys for today's and take care. Thank you guys.